That's all you did.
Yo, is it going to present? There we go. Yeah. We're all good? Awesome.
All right, give it up for Max.
Okay, today I'm just going to do a brief intro to Docker, how to use it, how to run it, how to build containers, everything forward with this. Unfortunately, my co-presenter, Danny Schloss, wasn't able to be here today. She's the Docker god. So first we need to go over that, the idea of what's the difference between containerization and virtualization. So containerizations aren't a full operating system. They're basically just a small... They're a container running on an actual kernel. They're using the same exact kernel as the actual operating system. It's kind of hard to exactly understand. There's not very many words for it, which is the hard part, but basically you're just running a containerization engine, which in a virtualization sense is your hypervisor, but this is strictly running containers, which is able to extend the kernel into your specific containers. So that's the generalization of what a container is. Using it, it's used for running just specific applications. It's extremely lightweight, and it's able to segment environments, and just the entire point of it is to containerize the environment so people can't break out. Of course, there's Docker 0 days and escapes and stuff like that. But if you're all updated and someone doesn't decide to drop a 0 day a couple days before a competition, you're all good. Also, very small overhead. Majority of the time, it's really just completely contained within the containerization engine. That's the entire overhead, and it's not too bad. With virtualization, you're gonna need a self-contained operating system. So you're loading an entire ISO onto the actual hypervisor itself, creating that virtual machine. That's taking resources, and you're running that entire guest OS with its applications, binaries, libraries, everything on top of your infrastructure, which is a lot more intensive than just running a container. But again, the benefit of that is you can run your own operating systems. You're not depending on your own kernel to run. So if you're in, I don't think there's really any Windows containers, but just say, for example, you were in Linux, you couldn't run a Windows container. If you're running on bare Windows, you couldn't run a Linux container. Of course, this is not 100% true, just because in Windows you can have something like WSL, which Docker uses as a Linux kernel itself, so it extends into the Docker engine, the containerization engine. And a lot more overhead, has its own, just pretty much everything. It's an entire operating system on itself instead of something that's just very small and segmented. In the photo, it looks pretty much the same, but the biggest thing is you're eliminating that entire guest operating system because, again, you don't need it. So Docker, oh wow, beautiful. It decided to change the indents. Okay. So it's I'm pretty sure it's the most popular containerization platform. There's a couple others. You really only ever hear Docker, at least I do. And like we talked about, runs natively on Linux and Mac. And if you're using Windows, you're going to be using WSL for it. And it's a very simple way of containerizing and orchestrating containerized apps. So, like we said before, containerized apps, it's just running an application in its own environment so that there's no way of it breaking out, given that there's not a 0 day, breaking out into your own into your own operating system. Very similar to virtual machines. I personally don't use it very much, but Docker has a really nice GUI. A lot of people use it, live by it, everything. And this just makes it really easy to run apps without any fear of someone, like, say you compromise the app, there's no way of someone in the compromised container to get onto your own operating system. This is something I use personally for demos, like, okay, you got root for medium 1. That doesn't mean that you're going to have root for hard 1. Stuff like that, once we get into specific breaks. Something we haven't used much this semester, but something we'll move forward with. Yeah, generalization, that's what Docker is. So to first build, there was another, okay, why did I put it there? Okay. That was supposed to be switched, it's not. So the base concept for this is a Dockerfile. A Dockerfile defines what an image is, and an image is later used to make the actual container that runs. So when we're looking at a Dockerfile, this pretty much just organizes everything in terms of what's going to be in the container, what environment variables it'll have, what on startup, what whatchamacallits are gonna, which binaries are gonna run, what commands you want, what volumes are attached, and it's built very easily. It's just a list of stuff to do. Some simple stuff. At the top, you're going to include a from statement. This is basically saying I'm building off this already pre-existing Docker image, and majority of the times you have a pretty much built from the bottom up Docker container, and then you're just editing some stuff in between. Your run is just executing commands like, hey, I'm going to be running SQL in this box. Run sudo apt SQL, apt install SQL. Cool. Command, this defines the command that you're going to enter your box with. So when it starts, say you want to have Apache running. You can have Apache run on startup like that. And that's always going to be like your final command or final-ish command. You can only have one command like that, if I'm not wrong. Label defines some like metadata for the container. Maintainer is very similar. It's deprecated now because of label, but like maintainer tells you who the maintainer of the container is. So I put my name there, and when someone like looks it up, they're like, oh, now I know who to yell at when this doesn't work. Label deprecates that, and now you can have a label of maintainer and then define yourself, as well as a bunch of other meta tags. Expose. So when we're looking at a container, it's just think of it as a closed box. You can't get anything out, you can't get anything in unless you poke a hole in it. So you want to, when you're exposing a port, you're on the inside saying, hey, this container can then see out using port 80. Cool. Environment variables, it's running its own environment. So say you want to have some kind of special, like, special environment variable. I'm just trying to think of special path. You want to add like a path variable. You do that through environment. Copy, that moves files from your actual environment to the containerized environment. So say you don't want to, I don't think there's even really a good way other than like echoing just your entire program into a single file, your entire program or file into a file on there. But copy allows you to like copy an entire directory right into the container. Add, it's the same as copy, but it works a little bit nicer. So with add, you can say, hey, add this web page that I found online, and it'll copy exactly that. Any files in it. It will also work with tarballs. So say you have something tar.gz, it will unzip that and send everything in where you want it to. Entry point is another really interesting one. So say you want to run your container, but you want to run it like a program. There's that idea of like, hey, it works on my box. So with Docker, instead of having to think and use every other person's box, let's ship my box. So let's make a Docker container that runs exactly like a program. So you have your entry point set. So your hello world just acts exactly like a hello world command, but it runs through the Docker engine. And finally, volume. More likely than not, for larger stuff, like say you want a SQL database on a Docker container, you don't want it so like if that Docker container ever like gets stopped and killed or whatever it is, everything dies, because that container pretty much just is kind of ephemeral. So volume allows you to share a volume from the Docker container onto the physical system itself. It's like mounting, but from Docker container to the container or to the environment it's hosted on. So just like a small Dockerfile demo. We're just going to be doing this real quick. Again, it's going to be super simple. Wow, cannot spell on this keyboard. So we're just going to make a dir called demo. Yeah, I haven't used this keyboard in about a year. So any Docker file will forever be called Dockerfile. That's just how it works. And Vim finally decided to work. So we can use that. We can use that from commands and say from HTTPD. So if you ever look up on Docker Hub, HTTPD is the image maintained by Apache itself. So when you use the from, you instantly have an Apache server that runs. I think it's running on the Ubuntu infrastructure if I'm not wrong. And then because it is already pretty much set everything we want, all we have to do is expose port 80 because that's where HTTP does and works. And we're all good. We got a Docker file there. Probably the simplest you can ever write. But we have a Docker file. And I guess I'll bring it up again, but it's literally from this container and expose this port. You can get 1,000-line Docker containers or Docker files and a lot more complex. But for this, I'm just going to be doing a sequence of like very small Docker files or small demos. So moving back away from that demo, I mentioned this before, but what's a Docker file compared to a Docker image compared to a Docker container? It's where it is in its life cycle. So Dockerfile is used to build Docker images. You can kind of see this. We're going to go into what Docker build and Docker run are. Those are commands in the Docker infrastructure. Docker files describe how the images are built. I talked about this before, like what resources, what information they have on the inside, what they're going to be running, stuff like that. Images are then just basically starting points for any container. So they're just static, like call it almost like an ISO, the equivalent of an ISO for containerization. So it doesn't actually store information once you start running it. It is just, hey, I'm going to copy this over, and then we're going to start running it on. Started and make the instance called the container. The image-based state of the container. Yeah, I already said that. Docker container is the actual running containerized app. I mentioned before this is kind of ephemeral. Like you kill it, there's no real good way to get it back up, or there might be. I've never. I don't know, but there's Docker is pretty much made so that say you kill it and start right back up, it's back to its initial state. This isn't made to be running the most complex app that needs to be up for, or that's kind of wrong because like even CTFD is on a Docker instance. What it's meant to be is if at any point you want to revert it to its initial state, it's very simple. You're just going to delete it and restart it, and you're all good. Or at least that's my belief around it. There's plenty of other beliefs around it, and I'm sure a lot of people are a little bit more correct around it. It's what it is. But we see a Docker file. That's just the file you're using to describe to make the Docker image. Docker image is then run to create a container that actually runs an application. So we talked about it before, but what is Docker build? So Docker build is a command that takes a Docker file. So this is what is actually going from that Dockerfile to a Docker image. It builds a wow, I just said that exact same thing. I wasn't going to repeat it. Dockerfile uses the .dockerfile, so unless you specify otherwise, it's pretty much going to use just the Dockerfile in your current directory. The tacp, the path, you can describe otherwise, but it looks for the Dockerfile in your current directory. TACF, not TACP. TACF is for another file, not path. TACP, never mind. Docker build, just like add we talked about, can use URLs. So say you have a Docker, a Docker file on a remote server or something. You have something on Docker Hub that you want to use. You can use the Docker or you can have the URL and Docker build and then that URL, and it just works. Or if you have a tar archive, you can then use that and it'll pull the Docker file from within. Yeah. And then another thing, these images then can be it's not like you're generating this and it's going to your current directory. It is going into just Docker's internal states, stuff like that. So it's using the Docker images command, you then get a list of all your current images, stuff like that. We'll go into it a little bit more later. And Docker build has a ton of commands for what you can do with it. Like just there's like 1,000 different, like, or I can't say 1,000 because I can literally count 6 CPU ones right there. But there is a lot of like how you can define how to build it and constraints you can put on it just initially. Always a good one is where is it? Tag. So normally when you build a Docker image, it's going to be referenced by its hash's name, but with tag you can tag it to be, say, I'm going to call this I don't know, 40-letter hash. I'm going to call it demo. Now we can just refer to it as demo instead of 40-letter random hash. So Docker build demo. Another really simple thing. We're doing our Docker build. So we go back here. We have our Docker file right there. We're doing a Docker command is Docker build, like we just said. We're gonna use a tag called demo so that we can actually refer to it as demo. And Dockerfile is in our current working directory. And just like that, it's gonna start running. It's getting the HTTPD, downloading all the stuff it needs, and it's building, extracting, and just making our Docker image right now. So successfully tagged demo latest. So like we said before, Docker images, lists them all. I have a couple on there, and these do get a little bit big, like 1.2 gigs. But we have demo, created 8 seconds ago, 138 megabytes. These aren't too small in terms of storage size, but definitely a lot smaller than making an entire VM and just putting HTTPD on it. But yeah, so that's that. That's our little demo on it. We'll use that again for the next demo. So Docker runs a Docker image and creates the container. So right now that Docker image really isn't anything more than just, like I said, a starting point, an ISO. Can't really just use it as is. So that's what Docker run does. You can use just like tact, you can use tact name to set a name for it, because again, you have an image ID which is a hash, and now you can set your container once you make it to have a name called, I'm going to name it demo again, just so we can have like some kind of concurrency. Other good options, tact detach. This is like almost putting the ampersand at the end so that it runs as a daemon, or I always call it a daemon. It's really just detach. But what is it called? It runs. It won't. Otherwise, you're going to literally have to control C to do absolutely anything else. This just lets you run it in the background, and then if you ever want to kill it, you run docker kill. Again, we'll get into that a little bit later. Say you want to get into your actual container, get into its actual Linux environment. Tech IT, I forget what those stand for. IT is I is interactive, and T is TTY, something with like processes, attaching processes or something. I forget exactly, but it's Tech IT. And then at the end, in that little like args section, you're gonna put IT in the options, and args you're gonna put bin bash, and it's gonna give you a bash shell for the actual image itself. And it's gonna be a very lightweight image, so there's not a ton. Like I don't think they have Vim or V or anything on there unless you installed it. But still, stuff like that. Oh, also another big thing, this is when you're gonna mess with your port mappings. So we know that we expose the image on port 80, and that can have it let out on port 80. For the actual containerization engine, it also has to have a mapping. So it goes, you can use an IP. I don't ever like using the IP. I'm sure there's some situation too. But TACP, whatever port you want it to be running on. So say you want this running on 5000, even though the actual container is only running on port 80. You can do 5000:80, and it will map your external port 5000 to port 80 on the inside, and just make like a small little tunnel. So that one's always cool. So you can have multiple websites all running on port 80 in their Docker containers, all in separate ports. So again, Docker run demo, something really simple. And so we can have our Docker run command like we said before. We're going to use the detach. We're going to name it demo, and we're just going to attach it 8080. So inside or outside 80, inside 80. Just make it a normal server. And then we're specifying the instance or the image, and again we called it demo. Gives us the hash back if we ever want to use that, such and so forth. And we'll go in Brave real quick, and we can see it running. Great, HP, why are you there? Localhost 80, it works. We got a server just with like 2 commands and like 2 lines of a configuration file. Cool. So we have that running, such as life. We'll just put that aside for right now, and we'll go back, and we had our little Docker run demo. Or actually, I'll show you. So there's Docker PS, which is process status. So it'll give us the current running ones, so we can see the name of its demo, the image is being used as demo, and we have the container ID, which is like the first, I don't know, however many digits of the hash, and you can refer to it by that or the full hash. And gives us our mapping. We're running on our current machine, port 80 to port 80 using TCP, stuff like that, when it was created, status of it. Yeah, a bunch of stuff like that. And there's also same exact command we'll get into before, but Docker container, because now we have a container, and ls, just like list. Wait, is it actually list? Container. Yeah. You can use ls or list. I spelled container wrong and spelled container, but that's the exact same way of doing it. I forget if it actually changes anything in it. Oh, the only thing that changes is the created time, but yeah, gives you the same exact information, just another way of doing it. There's talks about deprecating one of them, but like no one cares enough to, because they do the exact same thing, or all of them do the exact same thing. So other assorted Docker commands, Docker images, like we just talked about before, lists all the images you have on your box. Docker PS lists current running ones. Docker container ls, same thing. We just talked about that. Docker pull. So we were talking about recently Docker Hub and how they have images on there. So to get the HTTPD image where we normally had it, and why can't I think of it? Yeah, so that we don't have to refer to it by its URL, we can just run something like docker pull HTTPD, and it'll figure out, hey, you want to get it from Docker Hub, we'll pull that image down, put it in your images, you're all good, stuff like that, and then you can run it. You can use it without whenever you're trying to build one. As long as that's the most updated version, it'll just pull from your personal repository, so that you don't have to keep downloading the same thing over and over again. Docker stop stops a running container. Docker start, guess what? It starts a stopped container. So you're able to stop and start and pretty much just like suspend these. Docker kill, when you have it in the background as a daemon or detached, the easiest way to do it is Docker kill the container. Another thing, if you want to remove that container, because once it's killed, it still exists for whatever reason, you do Docker rm, just like the command remove, Docker rm container. And then I tried looking up the difference between Docker stop and Docker pause. Docker pause has something to do with its suspending current processes. Docker stop sends like an actual like sig kill. They do, as much as I understand, they do essentially the same. But Docker pause will pause all processes instead of stop them. And Docker unpause will unpause paused processes on a container. And another cool one, Docker port. This will show you all the port mappings, make sure that everything is running correctly. So Docker port, your container, and then if you want to get any more granular, you just put whatever port you have, and it'll give mappings. And if you want to get like another step into it, you can put /TCP or UDP, and it will only specify that one. A lot of people don't care enough to do that. But yeah. If we want to, I kind of don't like this demo because I put that in there just to spend some time, and we're already over. But yeah, I'm sure you can all figure out what those ones mean. Next big thing, this is pretty much the last slide. I was going to do another demo with Docker Compose, but I think we all got it. Docker Compose wraps up all those operations into a single YAML file. So this basically says, hey, I have this built. I have this, I have this Dockerfile. I want to bring it all the way from this to a running container with one command. How do I do that? So the Docker Compose run command just looks at the Docker Compose.yml file, and then Docker Compose can also build several containers. So based on your services, those are the containers themselves. So you can specify as many as you want, how you want to build them, if you want to just grab an image, absolutely everything, ports, any networks, volumes you want to map, commands you want to run, stuff like that. Pretty much everything you could ever want. You technically don't even have to make Docker files. I prefer to. I don't think you specifically have to. But yeah. And then you can run the Docker Compose up, and it looks at your current working directory, sees if there's a Docker Compose.yml, and we'll run it. So right there, you go all the way from your base, and you get a running container. And then you should use the tag-D option because that'll detach it. And if you use that tag-D to detach, you later just do Docker Compose down, and it'll put everything down, and you don't have to worry about anything. Just gives a lot more functionality. And I know I'm already over, and we're over, so I'll skip the next demo, which was Docker Compose, where I was just going to write a basic one. It's like 5 lines. I'm sure if you guys watch through this, it's simple enough. The other thing I want to preface is Docker Compose, you actually have to install it separate to Docker. Only thing that sucks, but easy enough. It's instead of like apt install Docker, it's apt install Docker and Compose. Pacman install Docker Compose, stuff like that. Finally, Anyone have questions? I know that was a slamming amount of information.
I have one question. How do you, when do you need to know how to download Docker Compose? Like, what's operating system? Is it just Windows or?
Docker Compose, I'm pretty sure works on anything. Yeah, I'm pretty sure it's just kind of universal. But Docker Compose, the biggest benefit of it is just not having to run all those commands in between, and you can do that with several different containers at the same time.
So you don't really need to download it? It's all
Well, Docker Compose is the command, so you need to download the command to use it. Anything else? Nice.
All right, awesome. All right, thank you, everyone. Thank you.